In this video, we will explore the reaction between acids and metal carbonates. Recall that an acid is a chemical that contains a special type of hydrogen that can be released into aqueous solution as a hydrogen ion, H positive. The most commonly used acids in the laboratory tend to be hydrochloric, sulfuric, and nitric. It's the release of positively charged hydrogen ions and not the presence of the negatively charged counter ion, chloride, sulfate, and nitrate, which confers the properties of an acid. One very quick chemical test for an acid is to add a little metal carbonate to it, such as calcium carbonate, or CaCO3. The evolution of bubbles of carbon dioxide are evidence that an acid was used. Geologists often dribble a little acid over an unknown rock sample. If fizzing is seen, then the rock is a carbonate. In neutralization, you might recall the general equation: acid plus base equals salt plus water only. Most metal carbonates are almost insoluble in water, but will react with an acid and so are regarded as a base. Acid plus metal carbonate equals salt plus water plus carbon dioxide only. Rainwater is a natural acid due to dissolved carbon dioxide. This is the weak acid called carbonic acid, which at higher concentration gives sparkling drinks their sour taste. When rainwater meets calcium carbonate, either in rocks or as part of buildings, there is a chemical reaction. This turns what is essentially an insoluble rock into a soluble material, which gets washed away. This is what creates underground caverns in limestone areas, and why acid rain slowly wears away historic buildings. To confirm that the gas made is carbon dioxide, we can use this simple setup to pass it through lime water, a solution of calcium hydroxide. After a few seconds, a white milkiness is seen, which is microscopic specks of insoluble calcium carbonate being made in the reaction. Don't let the gas bubble for too long, as the reaction will make carbonic acid, which reacts with the insoluble calcium carbonate to make soluble calcium hydrogen carbonate, as shown before, leading to a clear solution.